What's up guys, welcome back to the channel. Today on this video, as you can see on the screen there, we have this question paper, and this question paper, it's actually test 2, which is a common question paper for the following provinces, which are Gauteng and Free State provinces. Now this is N4 question paper. It was actually written on the 12th of March 2026, and it took about 2 hours to be written. Now we already done question 1, question 2, question 3 of this question paper. If you want to watch those ones, you can go to the description. I'll leave a link or a playlist that contains those questions, and also the very same playlist will pop up at the top right of this video that you're watching. So before we start though, I'm gonna leave timestamps for each and every question, just in case you don't want to watch this question in a sequence order. All right, guys. So before we do question 4 of this question paper, I would like to say thank you very much, guys, for watching, subscribing to the channel, commenting, not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel. All right, guys, let's look at question 4 and let's solve it. All right, guys, here is our question 4. Now, question 4 is integration. It consists of 6 questions and 2 sub questions there. So all in all, question 4 actually has 8 questions. So we're gonna start with 4.1 and then we're gonna continue to 4.6. So let me create space so that we can do 4.1. All right, guys, here is our 4.1. Now let's look at this question and let's solve it. As you can see here, they want us to simplify the following integral there. So what we need to do here, guys, is to first deal with what we have here. We have cos squared x minus sine squared x. This here, guys, is a double angle identity. So we need to simplify this one first. So let's simplify. So we're going to have sigma, and then we're going to write cos 2x dx. Remember, cos squared x minus sine squared x, that is a double angle identity for cos. Just in case you don't know much about double angle identities, I will leave a video on the description, and the very same video will pop up on the top right of this video that you're watching at the current moment. Go and watch that video to understand how we got to this cos 2x. Now that our expression is like this, we can start to integrate. Remember, when you integrate the trigonometric ratio, you first write the integral. So what is the integral of cos here? We know that the integral of cos is going to be positive sine 2x, right? Let's not forget 2x there. But since our x is the coefficient, we must divide by that coefficient, which is going to be 2 plus c. So this here, guys, is our final answer for this question. So I hope you managed to understand it. Just in case you did not understand, do not forget to ask on the comment, and also you can watch at the point where you got lost there. But this was straightforward as it seems here. If this helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Let's move on to question 4.2. All right, guys, let's look at 4.2. Now, 4.2, they want us to evaluate this definite integral that you see here. We need to integrate each and every term here before we actually evaluate. So when you integrate this, ln 3 is a constant. So remember, when you integrate the constant, you multiply by the variable that you're integrating with. In this case, it's actually x. So this is going to be x ln 3 minus 1 over x. That is actually the integral of natural log. So this is going to be ln x. There we go. But let's not forget we have the upper limit, which is 4, and the lower limit, which is actually 2, right? And then from here, we can start separating these brackets. We have y, which is going to be equaling to open bracket x ln 3 minus ln x. This here is for the upper limit, that for them, minus. And then for the second bracket is for the lower limit, which is going to be x ln 3 minus ln x. Guys, don't confuse these limits with the powers here, guys, right? So this limit is to show that the first bracket is for the upper limit and the second bracket is for the lower limit. Then we can start substituting. If we substitute here on the first bracket, we're going to substitute wherever there is x with the upper limit. In this case, that is 4. So 4 ln 3 minus ln, instead of ln x, it's going to be ln 4. There we go, minus. And then here, instead of substituting with x, we're going to substitute with 2 then. It's going to be 2 ln 3 minus ln 2. There we go. And then you put this on a calculator. When you put this on a calculator, your answer is going to be 1,504 unit square. There is our answer. Guys, these are definite integrals. Just in case you want to learn about definite integrals, there is a playlist. I'm gonna leave it on the description. Go and click on that playlist, and the very same playlist will pop up on the top right of the video that you're watching at the current moment. Go and watch the videos on definite integrals. All right, people, if this video helped you to understand how to solve this type of a problem, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. But if you couldn't understand, you can always rewatch at the point where you got lost, and you can leave a comment on the comment section, and I'll try to answer you to my level best. But this is how you do 4.2. Now that we are done with 4.2, let's go and do 4.3. Here is our 4.3. Now 4.3, it has this sub question that we have here. Now let's start by reading the question on 4.3. Now 4.3, they say consider the graph of y is equaling to x squared plus 2. Now 4.3.1, they want us to sketch and indicate clearly the area enclosed by the graph of y is equaling to x squared plus 2. Now we also have the coordinates there. We have x is 0 and x is 2. Also indicate the representative strip used to calculate the indicated area. So here we are given this graph here, which is a parabola, and then they want us to draw that graph. Also, they want us to indicate the area that is formed by these 2 points, 0 and 2, on our x-axis. So let's draw the graph, and then let's indicate this. Now, before we draw the graph, we need to find the coordinates of this graph. So let's start with when x is 0, what is our y? So we're going to take this equation here. Wherever there is x, we substitute with 0. So y is going to be equaling to, wherever there's x, we substitute with 0, and that is squared plus 2. So we can say this here, our y is going to be 2. So we can say point A, when x is 0, y is 2. Let's do the next intercept. When y is 0, what is x, right? So this time around, wherever there is y, we're going to substitute with 0. So we're going to have 0 is equaling to x squared plus 2, right? Then from here, we're going to transpose this. This is going to be -2. This is x squared. After transposing 2 to the left hand side, the next step here, we root both sides here. Now, if you root both sides, this is going to be error, because the square root of negative number is an error. So our x here is error. So don't worry, guys, if it's error like this, this means that we do not intercept on x-axis with this graph. We know that there is no interception on x-axis. Let's find the turning point, because this is still a parabola. So in order for you to find the turning point, there is this formula: x is equaling to -b over 2a, right? So look at our equation here. We have x squared plus 2 there. We only have a and c there. Now that we don't have b, we can just put 0 there. So x is going to be -0 over 2. Our a is 1. So x is actually 0 there, meaning y is going to be 0 squared plus 2 from the original equation. So y is going to be 2. So our turning point, the coordinates for turning point, it's actually 0 and 2. There we go. Now if you can pay attention, our turning point is the same as our point A there, the y-intercept. So let's draw the graph. With this now we can able to draw the graph. So I'm gonna draw the Cartesian plane here, and then we draw the graph. So here is our Cartesian plane. I hope you guys can see it. Now let's look at the points there. We have point A. Here's our point A. When x is 0, our y is 2. So this is going to be our point A there on our graph. And then we don't have the x-intercept. So meaning our graph won't intercept on the x-axis. But we do have the turning point here. Here's our turning point. It's similar to point A because when x is 0, our y is 2. This graph of ours should face upwards because a, the coefficient of x squared, is positive. So meaning our turning point is going to be there facing upwards. Now when you draw this graph, guys, remember we don't have x-intercept, so our graph is going to be like this. It's going to go exactly past at 2, but it's going to face upwards like that. So this here is our graph, guys. This is the type of a graph which requires you to understand parabolas. But this is how the graph is supposed to look like. Now, we are not done because on this statement, they want us to enclose the area from 0. Remember, x is 0 here and 2 as well. I didn't put 2 there. So let's put 2 there. Let's put 2 there. Let's say 2 is here, right? There's 2 there. So we have to enclose our area. So from 0, this is gonna be our 0 there, and 2 is gonna be somewhere there. So we enclose our area there. And then they say we must highlight the area. So let me highlight very quickly. All right, so this is the area. Now, they also want us to show the representative strip. So the representative strip, you can put it anywhere between 0 and 2 on x-axis and then show the strip there. Right, so I'm going to put it here, change in x. So this question here, 4.3.1, this is what exactly they were looking for. Let's not forget to label this graph y is equaling to x squared plus 2. There we go. But this is exactly how they wanted us to draw this graph here. I hope you guys understood this. Remember, the area is from 0 to 2 on x-axis, which is from this point to that point on x-axis. Right, people, if this part of the video helped you to understand how to solve this type of a question, do not forget to like, share, comment, and subscribe to the channel. If you haven't subscribed, subscribe to the channel. And if you do not understand, do not forget to watch at the point where you got lost. And if that doesn't help, do not forget to leave a comment on the comment section. I'll try to help you to my level best. Right, guys, we are done with 4.3.1. Let's look at 4.3.2. Let's look at 4.3.2. Here's our 4.3.2. Let's read the statement. Calculate using integration the magnitude of the area indicated in question 3.3.1. So here they want us to use definite integrals to calculate the area of the one that we just created there on the graph. Hence, I left this graph here. So, in order for you to calculate the area, there are a few things that you need to understand there. First of all, we need to use the definite integrals. So, with the definite integral, we have the upper limit and the lower limit. Now, where are we going to find those limits? Well, for this question, it's so simple. They are given to us. Remember, we have x, which is 2 there, the limit, and we also have x, which is equaling to 0. Those are our limit. So the bigger one is going to be our upper limit, which is 2, and then the lower one is going to be our lower limit, which is 0 there. Now, what you're going to put inside there is the equation of our graph there, which is x squared plus 2. There we go, dx. Now with this, you can able to actually calculate the area. So this is equaling to the area. So area is going to be equaling to, now we integrate everything that is inside there. So when we integrate x squared, this is going to be x squared plus 1 divided by 2 plus 1, right? Plus 2 is a constant. Remember, when we integrate the constant, we just multiply by the variable we are integrating with. In this case now, it's x. So this is going to be 2x. Then we close the bracket. Then we have the upper limit, which is 2, and the lower limit, which is 0 there. Now, let's simplify this one further. We have a, which is going to be, inside there, we have x cubed divided by 3 plus 2x, right? And then we have upper limit and lower limit. So I'm going to continue here on top. If you continue on top, we have to separate these brackets. The first one is for the upper limit, which is going to be 2 there, minus, and then the second one is for the lower limit, with the lower limit, which is 0 there. So what we have to do here is just substitute. So a is going to be equaling to, on the first bracket, we're going to substitute x with the upper limit, which is 2 in this case. So we're going to have 2 to the power of 3 divided by 3 plus 2 multiplied by 2. And then we close the bracket there, minus. And then on the second bracket is for the lower limit. We're going to have 0 to the power of 3 divided by 3 plus 2 multiplied by 0. There we go. And then when we use our calculator, on the first bracket, we're going to get 6.667 unit square. So this here is the area of this graph there, the one that we indicated in yellow. Obviously, this one's going to give us 0. Even if you don't write it, it's still fine, people. So I hope you managed to understand how to find an area when you're given a problem like this one. If this helped you to understand how to find an area, you can always like, share, subscribe to the channel if you haven't subscribed, and you can leave a comment as well. If it so happens that you do not understand, do not forget to also watch at the point where you got lost. And if that doesn't help, you can leave a comment on the comment section and I'll try to answer you to my level best. Guys, we are done with this question 4.3. Let's go and do the next question, which is 4.4. All right, guys, let's look at 4.4. Now, 4.4, they want us to integrate the following there. Now, you must make sure that we simplify each and every time before we integrate. So, while we are simplifying, we keep the sigma and then we simplify the terms. Let's start with the first term. The numerator on the first term, we have sine 2x. That is a double angle identity. You can always write it like 2 cos x multiplied by sine x divided by a cos x. Let's write cos x there, minus, and then we have 2. This one here, we have the sides or sets, so we can change that into exponent. We know that a root is the same as the power of half. There we go, minus. We have 3 there, plus 1 over a minus 3 cos, and then we have x over 3 minus 3 to the power of negative 4x, like that, dx, right? So we are not finished, because the second term, we still have x to the power of half on the denominator. So we need to take this to the numerator before we integrate. So we're going to continue and rewrite everything as they are. On the first term, we also have cos x divided by cos x. So we're going to be left with 2 sine x, right? Minus 2, the coefficient. Now, if you take the x to the power of half on the denominator to the numerator, our exponent there is going to become negative half. Then minus 3 plus 1 over a minus 3 cos x over 3 minus 3 to the power of negative 4x. Then we say dx then. Now that each and every term is simplified, we can start to integrate. So let's do it. Y is going to be equaling to, the first term we have 2 sine x. The integral of sine, we know that is going to be negative cos. So we have 2, the coefficient, multiplied by negative cos x. There we go. Right, the second term is the standard integral, guys. So first we have to multiply by the negative 2 there, the coefficient, and then from there we have x to the power of negative half plus 1. Then we must divide by the very same negative half plus 1. There we go. And then we move on to the next term. Now the next term there we have negative 3, which is a constant. When you integrate the constant, you multiply by the variable that you're integrating with respect to. In this case, it's x. So it's going to be 3 multiplied by x. There we go. Plus, we have also 1 over a. That is a constant because you don't have x there. So we have to multiply by x as well. So 1 over a multiplied by x. There we go. And then minus. Now we do the second last integral. Now this is a trigonometric integral. So first of all, we multiply by negative 3 there. And then what's the integral? Of course, it's supposed to be positive sign. So it's going to be positive sign. But let's not forget we have x divided by 3 there. We also need to divide by the coefficient of x, which is going to be 1 over 3. So let's do it. 1 over 3. There we go. And then we do the last one. So the last term here, guys, is exponential. Now first of all, we're going to write 3 to the power of negative 4x, and then we have to divide by the coefficient there, which is going to be negative 4 and then ln 3 plus c. So this here, guys, is the integral of all these terms here. So we need to create space so that you can simplify them further. Right, so let's continue. Now, if we start with the first term here, we know that we have to multiply these 2 with negative cos x. So our answer is going to be negative 2 cos x for the first term. The second term, we have to simplify it further. We have negative 2x to the power of half divided by half. There we go. Minus, we have 3x plus x over a minus, we have 3 sine x over 3 divided by 1 over 3 as well. Then let's look at the second last term. We have negative 3 over negative 4. That is going to give us positive 3. And then we have 3 to the power of negative 4x divided by 4 ln 3 plus c. Now we have fractions here. We need to deal with these fractions. So what you can do here, guys, you can do this. The denominator of the denominator, it will multiply the numerator there. Same here, this 3 is going to multiply that 3 there. So let's continue. The first term is going to be negative 2 cos x. And the second term, like I said, 2 multiplied by 2, that's going to give us 4 x to the power of half. There we go. We have minus 3x plus x over a. And then this term here, the third last term, is going to be 3 multiplied by 3. That's going to give us 9 sine x over 3 plus 3 to the power of 4x divided by 4 ln 3 plus c. So this here is the final answer. I hope you guys managed to get this one. Really, this is a polynomial when it comes to integration, but it was not that difficult at all. Just in case you want to watch more videos on this type of polynomials, I will leave a playlist on the description, and also that playlist will pop up on the top right of this video. Alright guys, if this video helped you to understand, do not forget to like, share, subscribe, and also comment to the channel. If you got confused somewhere while we're busy with this, you can always watch at the point where you got lost. And if that doesn't help, leave a comment on the comment section and I'll try to answer you to my level best. Alright people, we are done with this question, which was 4.4. Alright guys, let's look at 4.5. Now 4.5, they just want us to determine here. So we have this integral here, we just need to integrate, nothing more. So let's start. There's no simplification required here, we just have to integrate. I think the trick here is because we have fractions. So the first term we have 1 over 3, the coefficient. Now, what's the integral? Of course, we know that this is going to give us sine 2 over 3x. There we go. Then we divide by the coefficient there of x, which is 2 over 3 there. And then minus 1 over 5, the coefficient of sine there. So what's the integral of sine? So the integral of sine, we know that is going to be minus cos 5x divided by 5, the coefficient of x there, plus c, right? Then if you continue, because this needs to be simplified, on the numerator we have 1 multiplied by sine 2 over 3x, so this is going to be sine 2 over 3x divided by, on the denominator we have 3 multiplied by 2 there, this is going to give us 6, right? Divide by 3, like that, right? And then the next time we have this minus and that minus, they're going to give us a positive there. If we multiply, this is going to give us cos 5x on the numerator, divide by, on the denominator we have 5 multiplied by 5, it's going to give us 25 plus c. So our final answer here is going to be as following. We have y is equaling to sine 2 over 3x divided by, what is 6 over 3? That is going to give us 2 plus cos 5x divided by 25 plus c. So here, this is our final answer for this one. So this was not difficult, but if you did not understand how to integrate the trigonometric ratios, it might get challenging. We have done the integration of trigonometric ratios on the playlist. You can go to our playlist and search for the integration of trigonometric ratios. You will see how we have done this one. I hope you managed to understand this, guys. If it so happened that you did not understand, don't forget to watch at the point that you got lost. But if you manage to understand, you can always leave a comment, like, subscribe, and also share the videos to your friends. We are done with 4.5. Let's go and do the last question, which is 4.6. All right, guys, here is our 4.6. Now here they want us to evaluate the following integral. Now this integral, it's really not that difficult as well. All you need to understand is that this is an exponential integral. So when we integrate the exponential integral, first we're going to write y is going to be equaling to the coefficient, which is 5 over 7 there. And then we know that e to the power of 2 over 3x. And then we must divide by the coefficient of x there, which is going to be 2 over 3 plus c. Now the next step, we just have to simplify. Now we continue on the next step by simplifying. We have to multiply this 5 with e to the power of 2 over 3x. So this is going to be 5 e to the power of 2 over 3x, and then divide by, underneath there we have 7 multiplied by 2. This here is going to give us 14 over 3 plus c. So we have a fraction under a fraction. So what can we do here? We can multiply this denominator with that 5 there. So let's do it. So our final answer is going to be y is equaling to 3 multiplied by 5. This is going to give us 15 e to the power of 2 over 3x divided by 14 plus c. So I hope you guys managed to understand this. It was not really that difficult as well. It's just that it had lots of fractions there. Just in case you don't know how to integrate exponential integrals, there is videos on our playlist. Go and search for exponential integration. You will see lots and lots of videos that are based on this type of integration. All right, people, we are done with this question paper. I hope you managed to pass this question paper. I had a comment from one of the subscribers that they managed to get 80% on this question paper based on the videos that I'm uploading here. So guys, we are done. Thank you very much for watching. Till next time. Cheers.